Hi folks, welcome back to Math with Captain Rod. I'm making this video here to provide some applications of arithmetic sequences. So the one we're going to look at first here is number 18. This is on your handouts in the notes, where it says the distance that an object dropped from a helicopter is 16 feet in the first second, 48 feet the next second, 80 feet the next second, and so forth in an arithmetic sequence. Okay, what is the total distance this will fall in 5 seconds? Put D total here for 5 seconds. All right, so first of all, here's why it's an arithmetic sequence. To get from here to here, we are adding 32, and then to get from here to here, we are adding 32, and so forth. So it'd be pretty easy to write out a formula for the nth term. The nth term is going to be the first term plus the difference times n minus 1, and again, this is starting at n equals 1. So this term right here is for n equals 1. Now I would also point out that this is after it has fallen for a time, I'm going to put delta t of 1 second. Okay. Now that means that the last term after 5 seconds, let's see, the a sub n is going to be, now again, notice that the n equals 1 and the delta t equals 1 line up. You know, in some problems they don't. It kind of depends on the wording. Sometimes when, you know, one value is something, this might be a 2 or something. But here, this was the distance traveled for a time frame of 1 second. So for 2 seconds we would use n equals 2. For 3 seconds n equals 3. For 5 seconds we're going to use n equals 4. And when we take 4 minus 1, we get 3 out of that. I'm going to go ahead and calculate a value. Okay, and I get 112. All right, now what we want is the total distance traveled. So that's the sum of the sequence. And for arithmetic sequences, we can calculate it using this formula here. All right, so in this example, we're going out to n equals 5. So we're going to have 5 halves times a1 plus the a sub n, or the last value. If we go ahead and calculate a number for this, I get 320 feet. All right, now the other thing we could have done is we could have whoops, I'm sorry, I gotta back up here. I was just looking at that thinking, that seems like a little light to me. Being a physics person, I was expecting that to be a little larger. We gotta go back. I'm sorry. This was for n equals 1, 1, 2, 2. For 5 seconds, 5 minus 1 is 4, not 3. My bad. 4. So I'm going to have to calculate that value again. Okay, I get 144 feet. And now when we do our sum, n over 2 is 5 over 2 times a1 plus this 144, our nth term. Okay, and I get 400 feet. Now I'd like to point out another thing we could do is we could have just kept going with this. This was for 1 second, 2 seconds, 3 seconds. We could have just gotten the value for 4 and for 5 and then added these all up. And if you want to do that as an exercise, you should be able to add that up and get 400 feet. All right, so I think I'll pause this for a moment while I set up the second problem. Okay, I'm back, and it says, let's see, a display of cans in a grocery store consists of 36 cans in the bottom row, 31 in the next row, and so forth. All right, so we have the sequence here, 36, 31, and so forth. The top row has 6 cans, so the very last term there is a 6. Find the total number of cans in the display. Well, first of all, when we go from here to here, we're dropping by 6. And because it says arithmetic sequence, we can presume the next one is a drop by 6 and so forth. So the a sub n is going to equal 36 minus 6 times n minus 1. And again, this one right here is for n equals 1. And you notice you put a 1 here and you get 36 out of this formula. I think the first thing we're going to need to do is actually calculate our value for n. The last one here is a 6. Can you pardon me for just a moment. Sorry about that. Had a quick phone call or somebody knock at the door. All right, so the last value is a 6. So I'm going to go ahead and put that here. And let's see, we can subtract 36. You can divide both sides by -6. And then add 1. All right, so n is equal to 5, I know now. All right, now the reason I needed that is because this question, it says to find the total number of cans on the display. So that's going to be the sum of this sequence, which we can calculate using n over 2 times the first one plus the last one. Yeah, we don't need that. All right, so the n is now 5/2 times a1, 36 plus the a sub n, which was given in the problem. I'm going to go ahead and calculate a value. Okay, it's looking like 105 cans. All right. And again, you should be able to verify this by, subtracting 6, subtracting 6, subtracting 6 until we get down to 6, and then summing these all up. I'm just going to take a moment here, pause this, and look it over. Okay, I'm back here, and I'm glad I looked it over. My apologies for this. I think I'm just a little bit distracted here. When we solve this equation here, we don't get n equals 5. We get n equals 6. My apologies for that. So I got to go back and redo that. I'm a little short on time here, so I'm not going to bother redoing this video here. We're just going to put a 6. I think everything else is good. That's the first one. That's the last one. Okay, and I'm going to recalculate that value. Okay, 126 cans is what I get out of this. And again, we could have went back here, and when you're doing your test, I recommend for any reasonably small values of n that you go through and double check your work like this. Just keep subtracting 6 until you get the last one, and then add these all up and make sure that it matches your answer. So I think what I'll do is stop that video right there. I'll make another video for the very last problem on the handout. Have a great day.